Now we're going to put everything together that we've just learned, and we're actually going to add and subtract the rational fractions. Here's an example of what we're going to do. We can see we have 5 over 6x squared plus x over 4x squared minus 12x. And what we're going to need to do is find a common denominator for those two, and we're going to need to factor them to do that. So the first thing I did is I factored the two fractions. So for the first one, there is nothing that can be factored on the numerator or the denominator, so it remains 5 over x squared. But for the second term of the fractions, adding the fractions, I factored a 4x out, and that left me with x minus 3. So now let's find a common denominator. So I have, for the 6 and the 4, the least common denominator for those two would be a 12. And then I have x squared, and I have an x. So in the first fraction I had x squared, and the second one I had x. So between those two, the one with the highest power would be the x squared. So that would be in my common denominator. And then also I have an x minus 3 that is not in the first part, the first fraction, but it is in the second. So of course it would be the highest power of the two. So 12x squared and x minus 3, that's going to be my LCD. So now then I need to write the two fractions as equivalent fractions with the 12x squared x minus 3 as a common denominator. So for the first fraction I have 5 over 6x squared. It needs to become a new fraction with the new LCD. So the 6 over here is where I showed that. The 6 would have to be multiplied by a 2. The x squared is in the new LCD, so I don't need to do that. And then I'd also have to have an x minus 3 to get to the new denominator. So when I take the numerator times the same thing, I get 10 times x minus 3. Let's look at the second fraction. That is 4 over 4x times x minus 3. So I need to get to 12x squared times x minus 3. So the 4 needs to go to a 12, which I show over here. So it need to multiply by a 3. And the x needs to go to an x squared. So we can see that we'd also need to multiply an x. So the numerator has to multiply by the same thing. So I would have x times 3x gives me 3x squared. So now I'm going to take these two equivalent fractions and I'm going to add them together. So here where you see that I have these new equivalent fractions and I add them together. So for the numerator, that would be 10 times x minus 3 plus 3x squared all over my common denominator. So when I combine, take this 10 times the x, that's 10x. 10 times the minus 3 is a minus 30. Then I have 3x squared. So you can see that I rewrote that. 3x squared plus 10x minus 30. And so now let's factor that numerator. So I'm going to factor a 3 out. Actually, I can't factor 3 out. So if I try to do AC middle on this, I get 3 times a negative 30, that's a negative 90, with the middle number being a 10. So looking for two numbers that multiply to negative 90 and add to 10, that's not going to happen. So that numerator is already in its simplest form. So that would be the simplest form for my fraction. Okay, so let's go ahead and do some more examples. Okay, so for this one, I'm going to factor it. So I have x plus 1. Two numbers that add to 4 and multiply to 4. That would be x plus 2 squared minus 2, and I'm going to factor x squared minus 4, so that would be x plus 2 times x minus 2. Okay, so now let's get an LCD. For the first one, I have x plus 2. That's a factor, and I have two of those. Okay, so that's one of the factors I need to look at. You notice that I have an x plus 2 in my second fraction, and this one is the highest power, so that's going to be in my LCD. Now let's look at, that's it for the first fraction. The second fraction has x minus 2, and it's not in the first one, so that's going to have to be in the LCD too. So my LCD is going to be x plus 2 squared times x minus 2. So let's go ahead and convert these into that new denominator, fractions with the new denominator. So I have x plus 1 all over x squared plus 2, x plus 2 squared, and that's going to go to a new term that is going to have my LCD of x plus 2 squared x minus 2. So I need to multiply both the numerator and the denominator by x minus 2. So that's my term. The second term, which is 2 all over x plus 2, x minus 2. Move that out some. Next thing, move this over. Actually, hold on. If you can see that I've got some places here that I have some places I was going to do that work. So I'm going to go ahead and move it down there, and then we'll start again. Okay, I rewrote what I did up above so that it's in the places that I had previously put on this paper to show the work. So in this one, I have 2, my other term, 2 over x plus 2 times x minus 2. And that has to have the LCD of x plus 2 squared x minus 2. So what would this need to multiply by? Well, if I have x plus 2 x minus 2, and I have another x plus 2 squared here, this is going to need to multiply by x plus 2 over x plus 2. And so let's go ahead and do that multiplication for the numerator. That would be 2 times x plus 2. So now then I have a common denominator, and I've already written it down here so you can see that what I'm going to have, I'll have the fraction x plus 1 times x minus 2 all over my common denominator minus the second fraction. So when those two combine, I'm going to get, let's multiply these across by the FARL method. I'm going to get x squared minus x, then 2 times 1 minus 2. That's the first part, fraction multiplied together, and then I'm going to be subtracting everything that's the numerator here, so that would be minus 2x, then a minus 2 times this plus 2, all over my common denominator. Okay, now let's work on this a little bit more. I'm going to have x squared minus x minus 2 minus 2x minus 4 all over x plus 2 squared times x minus 2. Simplifying the numerator, I'm going to have x squared. I have a minus x minus 2x and I have a minus 2 and a minus 4. Be a minus 6. So now let's see if we can factor this numerator. So I need two numbers that add to negative 3, but multiply to negative 6. And 6 and 1 aren't going to work, 3 and 2 will not work, so that's already in simplest form because the numerator cannot be factored. Okay, let's do a few of these real quick. Some of these are pretty easy. Notice these have a common denominator, so that's just going to be equal to 3 minus 7 all over 2x. 3 minus 7 is a negative 4 over 2x. 2 will go into negative 4, a negative 2 times, so that would be a negative 2 over x. Now let's work this one. So what I have here is we're going to need to factor it. And I need two numbers that add to 6, multiply to 9. That would be x plus 3 squared. My next term would be 1 all over. That's a difference of squares, x minus 3, x plus 3. So let's go ahead and simplify the process that we're using to create a new fraction. So let's see what the LCD will be. So you can see I have x plus 3 over here in this fraction. I also have it over here. This one has a square in it, so that's going to be x plus 3 squared. And that takes care of my first fraction, so obviously x minus 3 is going to have to be in both of them. So my new LCD is x plus 3 squared times x minus 3. Okay, so now that let's take a look at my first fraction. I have x plus 3 squared. It's going to need to change to this denominator. So you can see that I'm going to need to multiply by an x minus 3 to create this denominator. So the numerator is going to have to multiply by that also. So when I do that, that would become my fraction. For the second term, the second fraction, I have an x minus 3x plus 3. Remember, it's going to have this denominator. And it's going to need to add another x plus 3 in the multiplication because I have 1x plus 3. Here I have x plus 3 squared. So my 1 would have to multiply by x plus 3 also. So let's go ahead and simplify this. So I'm going to have, in my numerator, I'll have x plus 1 times x minus 3 minus x minus 3 all over a common denominator of x plus 3 squared x minus 3. X plus 1 times x minus 3 is going to be x squared minus 2x minus 3. Then we minus x, because this minus would distribute in, and now it's a minus times this minus 3 would be plus 3. All over x plus 3 squared, x minus 3. Let's go ahead and simplify the numerator some more. So I have x squared, I have a minus 2x and a minus x. And I have a minus 3 plus 3. So that'll be 0. So my numerator is x squared minus 3x over x plus 3 squared, x minus 3. Let's factor the numerator. X times x minus 3 all over x plus 3, x minus 3, or x plus 3 squared. And now then, we can simplify out the terms. So what we have is we have an x minus 3 over x minus 3. Those are going to cancel out. And that's going to give me x all over x plus 3 squared. And we can see that when we look at this, right here, when I did my multiplication and addition, you can see that what I can't have is I need to specify the places where the denominator go to 0. I'm going to have x cannot equal to a minus 3, and x can't equal to 3. And I should have done that on some of these upper problems, but I didn't. For this one, we're going to have to say that x can't be equal to 0. For this one, we're going to have to say that x cannot be equal to 2. X cannot be equal to a negative 2. And let's see what we got here. And I think that's the same problem I was working on. And so that's adding and subtracting rational polynomials.